Now let's study ratios of complementary angles. What are ratios of complementary angles? As the name suggests, it is the ratio of complementary angles. What are complementary angles? If the sum of two angles is 90 degrees, they are called complementary angles. So if we take the angle theta, then its complement angle will be 90 minus theta. Now what do we mean by ratios here? Here, ratios means the trigonometric ratios. So we want the trigonometric ratios of complementary angles, that is sine, cos, tan, cosec, sec and cot of theta and its complement 90 minus theta. Now why use these ratios? As we have seen in the first chapter of trigonometry, fundamental identities, we had used those identities to prove the trigonometric identities. Here, we will be using these ratios to simplify the given expression and prove the required result or evaluate the expression. Now, how to use ratios of complementary angles? For this, we take triangle ABC, right angled at B. Let angle C be theta. So what will angle A be? It will be 90 minus theta, because sum of angles of a triangle has to be 180 degrees. Now from this we find the trigonometric ratios. Sin theta is opposite upon hypotenuse. In this triangle we will get sin theta as AB upon AC. Cos theta is adjacent upon hypotenuse, that will be BC upon AC. Now let's find out sin 90 minus theta, that will be BC upon AC, and find cos 90 minus theta, that is AB upon AC. Now here you will observe that sin theta is the same as cos 90 minus theta and cos theta is the same as sin 90 minus theta. So sin and cos are complementary angles. Similarly, we will get tan and cot as complementary angles and sec and cosec as complementary angles. So we have the 6 formulae for the ratios of complementary angle as sin 90 minus theta equals cos theta, cos 90 minus theta is sin theta, cosec 90 minus theta is sec theta, sec 90 minus theta is cosec theta, tan 90 minus theta is cot theta, and cot 90 minus theta is tan theta. Now the prerequisites for this topic are, you need to know the trigonometric ratios of special angles. That is, you must know sine, cos, tan, cosec, sec and cot for 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. Now let's start some problems based on this topic. First problem, prove that cos theta upon sin 90 minus theta plus sin theta upon cos 90 minus theta equal to 2. Now we start with LHS. Now in LHS we have cos sin and we also have sin 90 minus theta and cos 90 minus theta. Now we write sin 90 minus theta as cos theta because of the formula, and we write cos 90 minus theta as sin theta. So we have cos theta upon cos theta plus sin theta upon sin theta. that is 1 plus 1, which is equal to 2. So we have proved LHS equal to RHS. Now we take the next problem. Prove that cos 70 degrees upon sin 20 degrees plus cos 59 degrees upon sin 31 degrees minus 8 sin square 30 degrees is equal to 0. Now we again start with LHS. Here we have cos 70 upon sin 20. Now sin 20 can be written as cos 90 minus 20, and in the second term we write cos 59 in terms of sin as sin 90 minus 59 upon sin 31 as it is. Now the third term minus 8 sin square 30. What is sin 30? It is half. So the third term becomes minus 8 into half square. We simplify the first term as cos 70 upon cos 70 plus sin 31 upon sin 31 minus 8 into 1 upon 4. Now the first two terms, they cancel out and we have 1 plus 1. From the third term we have minus 2. So we get 1 plus 1 minus 2, which is equal to 0, which is nothing but our RHS. So we have proved LHS equals RHS. Let's take the next problem. Prove that sec 70 into sin 20 minus cos 20 into cosec 70 equal to 0. Now we obviously start with the LHS. Now in the first term in LHS we have sec and sin. First thing, we will convert sec to cosec, and then cosec can be written as 1 upon sin. And in the second term, we have cos and cosec. So we write cosec in terms of sec, and then we'll write that as 1 upon cos. Let's do this. We get cosec 90 minus 70 into sin 20 minus cos 20 into sec 90 minus 70. Now we use the formulae. Sec 90 minus theta is equal to cosec theta, and cosec 90 minus theta is equal to sec theta. We get cosec 20 into sin 20 minus cos 20 into sec 20. Now write cosec as 1 upon sin and sec as 1 upon cos. We get 1 upon sin 20 into sin 20 minus cos 20 into 1 upon cos 20. Now sin 20 cancels, cos 20 cancels. We have 1 minus 1, which is 0, which is nothing but our right hand side. So we have proved LHS equal to RHS. Now we take the next problem. Without using mathematical tables, find the value of x if sin x is equal to sin 60 into cos 30 plus cos 60 into sin 30. Now we are given this, we want to find x. Now we know the trigonometric ratios of special angles. What is sine 60? It is root 3 upon 2. Cos 30 will be the same as sine 60, which is again root 3 by 2. Then cos 60 will be half and sine 30 will be again half. We substitute that here to get root 3 by 2 into root 3 by 2 plus half into half, which is 3 by 4 plus 1 by 4 equal to 4 upon 4, which is nothing but 1. So sin x is 1. Now sine of what angle is equal to 1? We know sine 90 is 1. So obviously x is equal to 90 degrees. So we have found the value of x. Now let's look at our next problem. Here we want to evaluate the expression, that is to find the value for this expression. We have 3 sin 72 upon cos 18 minus sec 32 upon cosec 58. Now in the first term we have sin and cos. We convert them to the same ratio. That is, we can write cos in the denominator in terms of sine. We do this and get 3 sin 72 upon sine 90 minus 18. Now in the second term we have sec and cosec. We can convert cosec in the denominator as sec. So the second term becomes sec 32 upon sec 90 minus 58. We write this as 3 sin 72 upon sin 72 minus sec 32 upon sec 32. Why could we do this? Because of the ratios formula. We have sin 90 minus theta is cos theta and sec 90 minus theta is cosec theta. This can be simplified to get 3 minus 1, which is 2. So we have found the value of this expression as 2. Now let's take one more example. We want to evaluate this expression. Now here in the first term in the numerator we have cos and cosec. So we write cos in terms of sine and we can write cosec in terms of sine again, that is cosec is 1 upon sine. So that first term becomes 3 sine 90 minus 80 into 1 upon sine 10. The second term will be cos and cosec. So we write cos in terms of sine and cosec in terms of 1 upon sine. So the second term is 2 sine 90 minus 59 into 1 upon sine 31. Now in the denominator we have sine square 25 plus sine square 65. Now that sine square 65, we write it in terms of cos as cos square 90 minus 65. So the expression now becomes 3 sine 10 into 1 upon sine 10 plus 2 sine 31 into 1 upon sine 31, the whole thing upon sine square 25 plus cos square 25. This has been possible because sine 90 minus theta is cos theta, cosec theta is 1 upon sine theta and sine theta is cos 90 minus theta. Now the expression can further be simplified as 3 plus 2 upon Now what is sine square theta plus cos square theta? It's always 1, the fundamental identity. So we have 5 upon 1, which is 5. So the value of this expression is 5. Now let's look at the next sum. It's slightly of a different type. Here we are asked to find A for the following equations. The first equation is given as sine A is equal to cos 2A. Now sine and cos are complementary angles. So we write one of them in terms of the other. We can write cos 2A as sine 90 minus 2A. So the equation is sin A is equal to sine 90 minus 2A. Now we can equate the angles, that is A is equal to 90 minus 2A. Transfer minus 2A to the other side, we have 3A is equal to 90, that is A is equal to 30 degrees. So here we have used the formula cos theta is equal to sine 90 minus theta. Now the second part in this, sine 2A is equal to cos 3A plus 20 degrees. This can be done the same way, but here we can write sine 2A as cos 90 minus 2A, that is equal to cos 3A plus 20. This is possible because of sine theta is equal to cos 90 minus theta. Now we equate the angles and get 90 minus 2A is equal to 3A plus 20. Take A's on one side and numbers to the other. We get minus 5A is equal to minus 70. That is A is equal to minus 70 upon minus 5, which gives us 14. So A is 14 degrees.